Stephen Cuff has Parkinson's disease. Parts of his brain are dying, causing him to shake uncontrollably and slowing his movement.
It was about 4 years ago, and I had a slight tremor in my arm, and at the time I thought it was just a trapped nerve, so I didn't think too much of it. But as time went by, it started getting a lot worse, so I went into Salisbury for tests, and then they told me that I had Parkinson's. It took a while to sink in, but I had to deal with it the best way I knew how.
His disease is currently incurable and will continue to worsen as more brain cells die.
When I shave, I have to hold the shaver in this hand. I have to grow over with that hand and have to move my face rather than my hands to get enough pressure to shave, which is why it takes this nightmare, because after time I've got to go over and over again at the same place.
There has been much speculation that Stephen's Parkinson's disease could be treated by cutting-edge stem cell research, but the technology is still in the early stages, and much of the work relies on using early human embryos, something that is unacceptable to many. Meanwhile, Stephen's worsening condition and lack of response to drugs means that his only option is brain surgery.
I'm going to put the wires in my head and see what effect, or if any effect, it has in helping me with my shakes. And if it is a success, they'll plant them, and it'll hopefully give me more stability and more motion and mobility in my limbs, and I'll be able to do more things, which will mean I'll be able to look after my children, hopefully, which will be wonderful. They've gone to live with their mother, but I hope in the not too distant future that if things work out for me at hospital, that I'll have a chance of living with them again, because they want to come back to me, and I love my kids and I'll do whatever I can for them, and I miss them greatly.
At the Radcliffe Infirmary in Oxford, neurosurgeon Tipu Aziz is planning the complex operation that will treat the symptoms of Stephen's disease.
Parkinson's disease is a degenerative disease in which the brain, for reasons still unknown, loses a chemical in its substance called dopamine.
On either side of the normal brain, there is a small area of tissue crucial to the control of movement. The nerve cells or neurons in this part of the brain communicate by producing a chemical called dopamine. But in Stephen's brain, the dopamine-producing nerve cells are slowly dying.
The signs that a patient suffers from are tremor, stiffness of the limb, what we call rigidity, and slowness of movement. He hasn't responded enough to drug therapy, and therefore we've agreed to offer him deep brain stimulation to help improve his life.
One of the main functions of dopamine-producing cells is to talk to a nearby area of the brain also involved in movement. The message is slow down. The dopamine cells act like a brake on the second area. In Parkinson's disease, this message fades away as the dopamine cells die off. The nearby cells then become overactive, sending out numerous and conflicting signals to the muscles of the body, causing Stephen's symptoms. Deep brain stimulation works by inserting a wire into the overactive region of the brain and passing an electric current into it. The electricity acts like a jamming signal and reduces the overactivity, allowing Stephen to regain control of his body.
Well, surgery is never perfect, and the chances of success in Stephen are of the order of 9 in 10.
However, there is a risk that the wire could hit a blood vessel in the brain, causing a stroke or even killing Stephen. For the operation to be successful, Tipu must be pinpoint accurate. A millimetre either way could make all the difference. And for Tipu to know if he's hit the target, Stephen must be fully conscious throughout the operation. As the wires are pushed deep into Stephen's brain, his body is still shaking.
We'll start passing some current if you tell us what you feel. Give it a trim up first.
But as the electricity flowing to Stephen's brain is tuned to the right frequency, his tremor dramatically subsides. Having completed one side of Stephen's brain, Tipu's team then repeat the procedure for the other side, with equally stunning results.
How does that feel? Feels great, huh? Okay, now we'll take...
All that now remains is for the team to wire Stephen up to his power pack, which will be implanted under his skin.
Well, as you see, the operation went very well. He's lost the tremor and the stiffness and the slowness, particularly on his terrible right side. And we certainly improved his left side. And by his own words, he feels marvelous.
It's now 6 weeks since Stephen's operation. And although not perfect, he's a changed man.
I remember Dr. Aziz telling me to raise my hand, and I could raise my hand and open my fingers. For the first time in 5 years, to be able to open my hands up. I can't tell you what it's like to be able to just walk freely. And I couldn't get a stride in. I knew what I wanted to do, but I couldn't get that stride in. But now I can walk so freely, it's just like having 2 new legs. The box is there. It's permanently switched on, and all they do is put a little tiny computer. All they do is they press it on the skin, and they can like fine-tune me like a motor. As I was struggling to look after the children, and my long-term goal was to be able to have my kids back. This is Marie, my daughter. She's 13. She's a pain in the backside, but I love her to bits, and she's really good. And she helps me around the house and that when she comes to see me. Michael. He's responsible for breaking the glass window in my shed, kicking a football through it.
When you walk to the shops with him, he's much more faster. He's always in front of you, you can't keep up with him.
Even though he's getting better now, he does need the help as well sometimes as well, because he finds it a bit difficult and he sometimes is slow at doing things, but he's mostly quite quick at doing things. So, and he can smile now, because he never used to smile before.
It's lovely to be able to smile again. And although my hand's gone back a little bit, yeah, it has been a total success for me, really.
Although Stephen's operation is mostly a success, he still has some shaking, and his Parkinson's disease has not been cured. Scientists at the Roslin Institute in Scotland, where Dolly the sheep was created, are now working to try to find a cure for Parkinson's disease using stem cells. But what are stem cells, and how could they help?
The characteristics of a stem cell, and sometimes they're from embryos and sometimes from adult tissues, are that they have the ability either to divide to make more of the same type of stem cell, or to change and become cells of a different tissue.
Most cells in the body have a particular role that cannot be changed, such as liver, bone and nerve cells. Stem cells are different. They can divide and produce identical copies of themselves, and have the potential to turn into many different types of cell. There are 3 sources of stem cells: adult stem cells taken from tissues in the body, stem cells taken from blood in the umbilical cord at birth, or embryonic stem cells taken from the embryo at about 5 days old. Although embryonic stem cells have huge potential, many people think using them is wrong or unethical.
At the present time, the reason why embryonic stem cells are the most interesting population of stem cells is that we know that they have the ability to form all of the different cell types of the body.
Scientists are now able to make embryonic stem cells turn into the dopamine-producing nerve cells that die off in Parkinson's disease. The long-term aim is to put these cells into the brains of people with the disease and give them back their normal brain function. Unlike the deep brain stimulator operation, replacing lost dopamine cells with new ones would cure Parkinson's disease.
The work is really encouraging because for the first time people are putting dopamine-producing neurons derived from human embryo stem cells into animal models to test their effectiveness. I think that gives us an indication that this research is moving into the area when we will be able to think of treatment of the first patients within perhaps 3 or 5 years.
But it's not quite that simple. The use of embryos to produce stem cells is a hotly debated topic. At a recent stem cell conference in London, scientists and lay people were keen to put forward their views.
I can't honestly say that I have a strong position on embryonic stem cell research. I personally believe in all research, find out what happens, what's involved, and we can then make the decisions which are based on the ethics.
I've been an embryologist all my scientific career, developmental biologist, and I think you'll find most people that understand developmental biology understand where these cells come from. And the fact that they're human, I don't think is really here nor there.
I think the notion of mass producing our own species, just so you can destroy them to create things in a lab, is abhorrent. And you haven't got to be pro-life, you haven't got to believe the early embryo has a soul or is fully human. It's basically the beginning of one of us, and therefore we should respect it.
Of course, I understand that to some people the idea of doing anything with a human embryo is a deeply offensive idea. And, I understand and respect the difference of opinion.
My name is Alison Davis. I have spina bifida, osteoporosis and various other disabilities. I use a wheelchair full time and I run a group called No Less Human. No Less Human is a group for disabled people, families and carers, and we campaign for the equal right to life of all disabled people.
At present, the law allows scientists to experiment on embryos up until they're 14 days old. This is something that people like Alison Davis are opposed to.
I think it matters what we do to embryos because they are human individuals. They are at the beginning of all their development, certainly. But if you say they're just a bunch of cells, then you're forgetting that I also am just a bunch of cells. So is every human being who exists. It matters what we do to human beings because we have a duty to protect the most vulnerable.
But let's just consider the stage of development it's reached. It's so small, it's smaller than a grain of sand. It has about 200 cells. It will be weeks before a central nervous system develops. And that means that there is no possibility of it being aware. And because it lacks this particular consciousness, this particular aspect of being human, that would be the reason why, for me, it is acceptable to use those embryos in research or in therapy.
And this is where the dilemma lies. Some people believe that as soon as an egg cell is fertilized, it becomes a human being. Meanwhile, others say that an embryo develops gradually towards being a human individual, and that by the legal limit of 14 days, it is still just a ball of cells.
I think it's wrong to suggest that people who are opposed to embryo research are being oversensitive. Each of us began life as a single cell and then as an embryo. Embryos are not potential human beings, they're actual human beings. Human life itself begins at the moment of fertilisation.
I think that what's important in making the judgments about an embryo is that there should be a national framework. I think these judgments are too sensitive to be made by research workers, by the patients who might benefit, by companies who might make money from it.
I mean, I'd be first in line for ethical stem cell research, and there are ethical sources of stem cells which are already treating people with disabling conditions. But I couldn't possibly countenance killing vulnerable human beings because there might be something in it for me.